All right, in today's lesson, we're going to take a look at matter and its properties. If you're in the Zumdahl book, this is the chapter 3. This is the beginning of chapter 3. And you probably know the three states of matter, so I'm not going to waste too much time telling you what they are, but you should know solid, liquid, and gas as the three primary states of matter. It turns out there is a fourth state of matter. It doesn't occur on Earth very much. But it does occur in the universe. In fact, 90% of the universe is the fourth state, which is plasma. But because we don't deal with it, it only occurs in really, really hot places like stars, like our sun. We're not going to talk about it. So let's look at the solid, liquid, and gas. And just as you look at these pictures, you notice a few characteristics of each. Solids, the particles that make up a solid, end up in a structured, densely packed material. And one thing that's interesting about solids is they do not take the shape of their container. If you put a penny in a jar, it stays in the shape of a penny. So the volume and the shape of a solid are fixed. If you look at a liquid, in a liquid, the particles have more freedom. They can move more. And in a liquid, we say that the volume of the liquid is fixed. If I pour 1 liter of Coke into a 2-liter bottle, I still just have 1 liter of Coke. But what does change is the shape. The liquid can take the shape of its container, so its shape isn't fixed, but its volume is fixed. And our third state of matter is gas. When you look at gas, it doesn't have a fixed volume, and it takes the shape of its container. So that means if I have a 1 liter balloon and I let the gas out into the room, and let's say the room is, 200-liter room. It's a big room, lots of space. Over time, that gas will eventually expand until the particles of the gas are everywhere in the room. So gas will expand to fit its container, and it will increase its volume. It can change its volume. Okay, so to sum it up, solids, the volume is fixed, doesn't change, the shape doesn't change. Liquids, the shape can change, but the volume cannot change. In a gas, both the shape and the volume can change. And in this slide, you can see, I think, the idea a little bit more. Here's a solid cube placed in a fish tank. It holds its shape. It has a fixed volume. A liquid takes the shape of the container, but has a fixed volume. And then a gas will end up filling the shape of its container. All right, so now let's talk about properties that materials possess. There are two types of properties that matter can possess. The first is a physical property. Physical properties are properties that are observed, such as color is a physical property. Mass is a physical property. Density is a physical property. Okay, so these are all properties that can easily be observed. A chemical property refers to the ability of a material to change itself into a new type of compound. So, for example, wood burns in air to form charcoal. And what's interesting, when you watch a piece of wood burn, what it's doing is actually taking some oxygen from the air, it's combining with whatever's in the wood, and it's forming charcoal. Now charcoal, is those black cubes that you put in your barbecue, but actually when you see a log and it's burned and it's black, that's charcoal. Another one would be, you could say vinegar reacts with baking soda, and it forms carbon dioxide gas. And if you've done this as a kid, you know the famous volcano, you pour the vinegar in and it foams out. It's amazing, but that's a chemical property of vinegar, that it will react with baking soda. And so this, in summary, ties up the physical properties and the chemical properties. There are many more physical properties that I didn't name. We could say volume, we could say odor, and so on. Now, last thing is the changes that these can undergo. So on the next slide, we're going to take a look at changes. Okay, so when we talk about physical and chemical changes, a couple notes. I want you to imagine I have a beaker of water. So I'm going to put some water particles in here. So there are the blue water particles. Okay, a common misunderstanding about physical and chemical changes. A physical change does not change what the substance is. So if I take this water and I boil it, right, I now have water, and instead of being a liquid here, it's a gas. And that seems like you've changed substances, but actually, as we saw in the last video, gas water is the same as liquid water. It's still the same particles, they're just more spread out. So boiling is considered a physical change because it doesn't change what the particles are. It just changes how they look. Another change would be if we were to turn this into ice. If we were to make ice, let's make an ice cube. Right now the particles are really close together. Still though, they're still water particles. Ice is water, gas is water, liquid is still water. So boiling and freezing are two types of physical changes. Other physical changes would be cutting, folding, right? These are all things you can do. Crumpling, right? You crumple paper, you're just changing its physical appearance. Crumpling. Okay? Chemical change, however, changes the substance. So an example of a chemical change is wood burns in air. The wood has undergone a chemical change because now it's no longer wood. It's now charcoal. Right? Food digests in your stomach. Well, I don't have to tell you this, but after you eat, within several hours, that food is no longer food. It's being transported to all different parts of your body for nutrients. And so that's a chemical change.